Yes, welcome students. Today we are going to discuss the next topic from module 4, that is characteristics and quality attributes of embedded systems. Now here you're going to discuss what are the important characteristics of the embedded systems and the quality attributes, various quality attributes of the embedded system. Now generally in this world, anything you take, every object has its own characteristics. Similarly, embedded system also has its own unique characteristics. So that is what we are going to discuss in the today's session, and then we are going to understand the quality attributes, the attributes which contribute to the quality of the embedded system. So now irrespective whether the system is an embedded system or a general system, or in other words a non-embedded system, so every system will have a set of characteristics, and what those characteristics are going to do, they're going to describe the system. They define the system, or it's going to define the behavior of the system. In general, whether it is an embedded system or a non-embedded system, so there will be a set of characteristics associated with the system. The non-functional aspects that needs to be addressed in embedded system design are commonly referred to as the quality attributes. Now you understood, any system you take, it has some characteristics associated with it, and similarly it also has the quality attributes. Now what are quality attributes? Quality attributes are the non-functional aspects. Say they are not related to the services offered by the system, but they are related to the behavior of the system. So I can give an example for this. So if I take a bicycle, now what kind of characteristics it provides? It provides, or characteristics I can call it, or I can also call it as a service. Characteristics or the service provided by the embedded system or any system in general. Now if I take a bicycle, it provides the transportation service. Now and if I take a motorbike, so that also provides the transportational service. So that is what the characteristics of a bicycle or a motorbike. They provide the service of transportation. Now coming to the quality attributes, now or you can also call them as non-functional aspects of the embedded systems or any system in general. Now this quality attributes or non-functional aspects are not related to the services offered by the system, but they are related to the behavior of the system. Now the same example, if I take bicycle and a motorbike, both of them are providing the transportation service. They provide the transportation service, but the quality wise they are different. Now bicycle goes 10 kilometers per hour or 15 kilometers per hour, but motorbike can go up to 60 kilometers or 80 kilometers per hour. So this is described the performance wise they are different. Both are providing the same service, that is the transportation service, but they are differing by their behavior. So bicycle can go up to 10 or 15 kilometers per hour, but a motorbike can go up to 60 or 80 kilometers per hour. So ultimately both of them are providing the transportation service, but they are differing by their behavior. So the performance of the bicycle is low because it can go only up to 15 kilometers per hour, but the motorbike it can go up to 80 kilometers per hour. So that is what is the quality attributes, or the non-functional aspects. They are not related to the services offered by the system, but more related to the behavior of the system. Now what we do now, the embedded system, the design should take into consideration both functional and non-functional requirements of aspects. Now when I say characteristics, it is functional, and when I say non-functional aspect, it is the quality attributes. When you are designing any embedded system, both things should be taken into care. So the functional aspects as well as the non-functional aspects. When I say functional aspects, they are more related to the characteristics of the services offered by the system, whereas the non-functional aspects are more related to the behavior exhibited by the system. I gave you the example also. Now what are the main important characteristics of the embedded system. Now, embedded system has its own specific characteristics, and these characteristics are unique to each embedded system. That means the characteristics what we are going to discuss now, so they are not generalized across all the embedded system. So the characteristics varies from one embedded system to the another embedded system. Now the major important characteristics of the embedded systems are: one is application and domain specific characteristics, reactive and real-time characteristics, operates in harsh environment. That is one more important characteristics of the embedded system. I don't tell all the embedded system will operate in the harsh environment. There are few embedded system which operates in the harsh environment or the difficult environmental conditions. So there are embedded system which operates in the distributed environment. So small size and less weight. Correct? This is also one of the important characteristics of the embedded system. And power concerns, because majority of the embedded systems are battery driven, so hence power concern is also one of the important characteristics of the embedded system. Now first we'll understand the first characteristics of the embedded system, that is application and domain specific. Now if you take an embedded system, it performs a certain function. It cannot perform variety of functions. Embedded systems are designed to perform a specific function, or in general it has some functions to perform, but not variety of functions. It can perform so one or few functions. Now, embedded systems are developed to do only intended functions. Now they are not developed to perform the general functions, to variety of functions. They are designed in such a way that they can perform only intended functions or the dedicated functions. So they cannot be used for any other purpose. That means they are not general purpose. So they can be used only for the specific purpose for which they have been developed. Only that intended function, a dedicated function, it's capable of performing. That is what is application and domain specific. It is not a general system. It is a dedicated system. And all embedded systems are dedicated systems, and they are designed to perform a single function or a specific function or a dedicated function. Now, and this is the major criterion. This is one criteria. What criteria? This dedicated function is the major criteria that distinguishes the embedded system from the general purpose systems or the general computing systems. Because when I say general purpose system, it's capable of performing variety of functions, whereas the embedded system can perform only an intended function or a dedicated function, and this is the major characteristics that distinguishes the embedded system from the general purpose system. So for example, I have the examples also. So for example, now why we say it is domain and application specific. So we cannot replace an embedded control unit of a microwave oven. Say for example, now I have already microwave oven is the best example for the embedded system because it has a microcontroller inside it. Now I want to replace the embedded control unit of your microwave oven with an air conditioner embedded control unit. Can I do that? No, I cannot do that, because so this embedded control unit or air condition is designed to perform a specific task, and this here is designed to perform a specific, that here it's controlling the temperature, and here again controlling the temperature, but still I cannot move it. This is only used for heating purpose, and this can also be used for cooling purpose. Now also you cannot replace an embedded control unit developed for a particular domain, say for example the telecom domain. So there are embedded systems or the embedded control unit which are designed to perform in the telecom industry. Now, is it possible for me to use those embedded control units which are designed for the telecom industry in the consumer electronics? No, not possible. So that is what is application and domain specific. And every embedded system is designed to perform a specific function or a dedicated function. So the second important characteristics of the embedded system is reactive and real time. Embedded systems, they are always in constant interaction with the real world. Now they make use of the sensors. Now through the sensors, they will be constantly interacting with the real world, and through the sensors they will be getting the data into the embedded system. That is what they do, and all the sensors, they are connected to the embedded system through the input ports. In other words, in general, I can say embedded systems are always in constant touch with the real world through the sensors, and the sensors will be sensing the data, what's happening around the real world, and they'll be giving the data to the embedded systems. Now any changes that happens in the real world, now and the changes, we can call them as an event. It may be the decrease in the temperature, increase in the temperature, humidity, all these things. Any changes that happens in the real world are immediately captured by the sensors, or you can call them as input devices, and the data that is captured by the sensors is given to the controlling algorithm or the firmware that is present inside the embedded system. And this embedded system, the firmware which is present inside the embedded system, is going to react in the manner in which it is designed to behave. And then by behaving in that manner, it's going to control the output variable to a desired level. Now, output variables are connected to the actuators, and we have already understood this in the previous contact sessions. And the controlling algorithm, using the data that is given by the sensors, it will react accordingly, and then going to control the output variables which are connected to the actuators. And you have some action being done by the actuators. And again, this reactive, that means why they are called as reactive system, because the embedded systems are capable of reacting based on the inputs that are sensed by the sensors. So hence they are called as reactive systems. And how often they react? So there are two possible things. One is periodic one and unpredictable one. So it depends on how the embedded system is designed. If the embedded system is designed to react periodically, then it will be reacting periodically. If the embedded system is designed to react in an unpredictable way, it reacts in an unpredictable way. Now that is what is. The event may be a pain. So the event which is occurring in the real world may be a periodic one or unpredictable one. If the embedded system is designed to handle the events that are occurring at the periodic interval, then it periodically gets the input, and the control algorithm behaves and produces the output variables to the desired level. If the event that is happening in the real world is unpredictable one, and again we don't have the embedded system also reacting periodically, and even it also goes for unpredicted behavior. Yeah, real-time system operation means timing behavior of the system should be deterministic. That is what is real-time system operation. Now, if you are able to determine that the system is going to complete the task in this time, then it is real-time system. That is what is deterministic. You are able to determine it, meaning that the system should respond to the request of the task in a known amount of time. If the system can do that, then we say it is a real-time system. If it is able to respond to any request or a task in a given amount of time period, then we say it is a real-time system. And again, when you say the real-time system, by any chance it should not miss any of the deadlines of tasks or operation. All the tasks of the operation, they should get executed and complete the task within the given time limit. And it is not necessary that all the embedded system should be in a real time. And there are few embedded systems which should behave in the real time. Say for example, there are some embedded systems which are called as mission critical systems. For example, flight control system, ABS, anti-lock brake systems which are used in the automobiles. are the examples for the real-time systems. That means in all the systems, so the delays are not entertained. So the task should be performed within the designated time period. So that is what is real-time system. And when you're designing an embedded system, as a real-time system, you should also take into account the worst case situation, worst case scenarios. That is, you should go for testing the embedded system not by taking only the lighter load. You should also go for testing the embedded system by loading it heavily. That is what is worst case. Load the embedded systems heavily and observe whether it is capable of completing the designated task in a given time or not. If the system is not able to complete the given task in a designated time, then it is not a real-time system, and if you deploy this for the use, then there may be a lot of problems. It may be a problem or a threat caused to the human life, or it may be a threat caused to the physical environment or the surrounding. So that is the reason when you are designing a real-time embedded system, you should take the worst case scenario into consideration. So best case, average case, and worst case. For all the three cases, you got to test it. And the number of tests which you do for the worst case must be more than compared to the number of testers which you will be doing for the best and the average case. Now, what is the meaning of worst case? So overloading the real-time embedded system and then testing to check whether it performs all the designated tasks within the stipulated time period or not. Now, the next important characteristics of the embedded system is operates in the harsh environment. Now, when I say embedded systems, so few embedded systems will be deployed in the controlled environments or the safe environments, but this need not be the case all the time. So there are embedded systems which are deployed in the very difficult environment situations or the harsh environment situations like dusty one. So where it is not possible for human to survive. Now, high temperature zones, even you can the embedded systems are deployed in the high temperature zones, and some environments where there are more vibrations and shocks. So that is what is the embedded systems can also operate in the harsh environment. Embedded system can also be designed to operate in the difficult environmental conditions. And when the embedded system is designed to operate in such harsh environment, it should be capable to withstand all the diverse operating conditions. If an embedded system is designed to operate at the temperature zone, it must be in a position to withstand all the high temperature. The design should take care of operating conditions and the area where the system is going to be implemented. So for example, if I want to develop an embedded system and deploy it in the high temperature zone, then all the components which I am using in order to make that embedded system should be high temperature grade. Because I don't want my embedded system components to get melted out because of the high temperature zone. So this is what the care or the consideration which you should look in when developing an embedded system which operates in the difficult environmental conditions or the hard environmental conditions. And when you are designing such embedded systems which operates at the harsh environment, you cannot compromise on the cost. The components which you use in such embedded system must be the durable components and which are capable of withstanding such a worst environmental conditions. And all the proper techniques should be provided, and the mechanism should be provided where the embedded system or the components of the embedded system under such environments can withstand the worst part of the environmental conditions. Power supply fluctuations, corrosions, and component aging are some other factors that needs to be taken into consideration when the embedded system is made to operate in the harsh environment. So the components which you use in the embedded system, so where it operates in the harsh environment, should not suffer from the corrosion or the immediate component aging. So all the components which you use in such embedded systems must be of long life. So the next important characteristics of the embedded system is distributed. The embedded system, this term is used to mean an embedded system which may be a part of the larger system. That means an embedded system is a part of some larger system. So many number of distributed system, they all like this, or when you integrate larger number of embedded systems like this, they make a single large embedded control unit. And if I look into the one embedded system which is inside it, it is distributed. Now example, a mini, say automatic vending machine, a chocolate vending machine or a coffee vending machine. So the best example for it, because this automatic vending machine is a collection or integration of many such distributed embedded systems. So for example, when I say automatic vending machine, inside it has a card reader. Card reader is again an embedded system. And then there is a vending unit. Vending unit itself is another embedded system. A card reader, what it will do, it will read the card of the user and checks whether the user is genuine user or not. And the second one, the vending unit is responsible for dispensing the appropriate material to the user. So this is, and when all this embedded system they make the larger embedded control unit, they work together to perform the overall vending function. Now if I take only the card reader, yes, it performs its designated task. Now if I separate this card reader from the vending unit, so maybe it will not provide the function of vending, but it provides definitely the function of card reading. It reads the card, but it will not get the function of vending function. Now another example is the well-known one, automatic teller machine, the ATMs, which you people have used and using even today. ATM, again, it's a collection of many embedded system, because even in ATMs you'll find the card reader embedded unit. Card reader is there, and there is a transaction unit which performs the transaction. That is one more embedded system. There is a currency counter, that is another embedded system. There is a printer unit which will print the transaction receipt for you. Now all these embedded systems are making one a large embedded control unit, that is automatic teller machine. And these are all and each of them I can call them as a distributed embedded system, because the card reader is used here also in automatic teller machine, and it was used in the automatic vending machine also. Now another example which you can give is a supervisory control data acquisition SCADA system, so which is used in control and instrumentation application. Now here in the previous two examples which I took, automatic vending machine and the automatic teller machine, all these components were integrated and made as one single large system. But in SCADA, so all these are physically distributed individually. So you don't find all the components or all the embedded system which are making the SCADA system in one single system. They are distributed, individual embedded control units, and all of them are connected by using a supervisory model. And again, it's a distributed embedded system. Now small size and weight, this is the fifth important characteristics of the embedded system. Now these days, because of the technological advancement, the device miniaturization is happening. That means any device you take, its size is shrinking. The size of the devices are being reduced, and that is because of the technological advancement. And the same thing is happening with respect to the embedded systems also, because majority of the embedded systems are handheld devices, and you cannot have them too bulky, and the embedded systems must be small in size. So the product creativity or miniaturization is an important factor in choosing a product. So when you want to buy any embedded system or a product, so including your cell phone, now the first thing that you look is the small size and lightweight. Now for example, now if the cell phone itself, if you want to buy a mobile phone from the mobile phone for yourself, you'll do a comparative study, you'll understand the pros and consequences of the various types of products available in the market, and then when you're doing all these things, definitely that you consider one important thing is the size, weight, shape and style. And this is what you people look in while choosing a mobile phone from for your own use. And people also believe in the phrase the small is beautiful. Now what we expect is a device that is small and slim. And moreover, why we believe in this phrase, because it is very difficult for us to handle a bulky product, and that to embedded system which are handled devices and which are carried in our pockets. It's very difficult to handle if they are too bulky, and this is one more important characteristics of the embedded system.